Alright, so this here is our Alley Bradley Slick 503. Kind of used to power a project. Input cards, output cards, module PLC. We got most of our lights and stuff, the 120 volt running off of this output card here, 120 volts in. Most of this output card here, the 24 volts coming in, or the outputs. We got some terminal strip down here, a bunch of ice cube relays. This one's for our final drill, the boat fan. This is our solenoid valve. A couple others we didn't label here. Some of our outputs are powered through these contacts. They go to these receptacles. This is actually a split receptacle here. This powers our final drill to lift up the present. And then this is for our Christmas lights are actually on all the time, normally closed contact. And then the drill's on a normally open contact, so when the coil's activated, the Christmas lights shut off, the drill comes on. And then once the drill's done timing, which is through a timer on the PLC here, and then our Christmas lights turn on, drill turns off. Gets a pretty good effect, really simple though. On the side here, we got our 6 lights. They're 120 volts, so kind of kept them local over here. This is our master on and off for our inputs and outputs. When it's down, the relays will still go. It shuts it off on the PLC though, so nothing else gets triggered or tripped. So while we're setting up, we trip a prox and it doesn't set off anything we're not ready for. Over here is our 12 volt stuff. We got 12 volt power supply here. Actually another one down here we needed, because it was our solenoid valve and the solenoid itself would use all the power in this. It would trip out our prox sensor, and then the PLC would think that the prox sensor had been made when it really hasn't. It just lost its power, and so then our drill would be raising up at the end, raising up the present before we were all ready. This is an absolute nightmare over here. We tried to make it as best we could, but it got pretty crazy. These are all actually 12 volt car relays we got out of the junkyard. Our proxes are mostly powered by the 12 volts, so it's all safe over there with the water and all that kind of stuff. They come back over here, and then we have our 24 volts DC or our 120 volt AC going up to our input cards. And so that way it can interface with the PLC. We kind of filter it through all that. That's this whole thing off is this here cornhole board. Some of the guys had this idea, and we figured, what the heck, we'll go for it. So we we were kicking around the idea of making a cornhole game originally, but then we decided to go with this route. And so we wanted to still incorporate something with the cornhole board. And so underneath it here is a little automation direct prox sensor. And it's got a reflector over here on this side. I'm not going to try and get under there to see it, but so that's just there shining, waiting for something to break its beam. I don't know if you can hear that relay clicking there, but so when somebody makes a cornhole shot, we got the great big cornhole bags, and so it definitely breaks the beam. Pretty reliable. Haven't had any issues with this at all. Originally it was just taped under there, and it would start to fall off and stuff, so we did have some issues there, but we got some screws and just gently screwed it into the bottom of that so that we wouldn't have any issues with it walking around on us or losing it. So that was really reliable. It's a pretty neat way to start it, get some people a shot, see if they can make it or not. And that's what sets this whole contraption off. Our little GFCI receptacle here, we got an on and an off, so we could shut off all of our 12 volts power supplies and stuff like that for when we leave for the day or whatever like that. It's also a GFCI receptacle, so that's add a little added safety there. We got some wire loom here. A lot of it's Cat 5, as you saw. It's a really good for using the prox sensors and 12 volt DC and stuff like that. Wire loom over here. This is Noah's project that he made for the DC motor project in second term, the ski lift that goes around. As you can see, his little chairs here. It's pretty slick. A 12-volt motor. He had to get a new one, one with a. They could get a better set screw because it just wasn't holding on good enough. He went to glue it in, and it did kind of get a little lean in there, but it works great. Absolutely great. Little proc sensor here. This is what is, as you can see on Automation Direct, just a little cheap proc sensor, NPN. We got a little reflector up here that it shines on, and the chairs are, kind of flimsy. So, but just they go around just enough to trip that proc sensor and then activate our counter on our PLC. Then we got our solenoid here. It's out of a car. It's actually out of my car. Somebody had tried to put electronic locks in my car that doesn't have it and never finished. But I knew this was in the door from pulling it off before. So we went off the parking lot and pulled that out of the car. We were able to use that, so that didn't cost nothing there. Got the dominoes going down here. And this here, it's actually a single pulse switch in the on position. Noah actually built this thing here. I've got a domino with some wire on it, and just set it here so this falls and makes contact there, and that's one of our inputs. Don't know if that clicking of the relay over there is showing up on the video or not, but this is pretty reliable. Obviously, there's a little bit of a adjustment that needs to happen in there to get it to work perfectly, so sometimes it does miss, but for the most part, it's really, really good. Then we move over here. We'll wait on that business there. So I got a few extension cords ran over here, power different stuff. In the sequence of events here, this is our next thing. This is actually my motor control project. A little drill here I built out of some electrical LB fitting, some little electric parts, a little shallow box here. It's got a cover on the other side. I had this white PVC pipe laying around, so I used it instead of actual conduit. End piece here, whittled that off a little bit, drilled out that circle. It had 3 screws for the end of the motor, a little DC motor in there. Bought the set screw coupler, kind of had to buy that. The shaft on these DC motors that they gave us for our projects was not in the center, and so it was a little offset. And it was pretty small and short and everything else, so we got a set screw coupler to make it work a little bit more reliably. Anyway, it's got a little board in here. It's got forward and reverse, and on the back it's got a potentiometer, so you can actually adjust the speed of stuff here. We pretty much just set it and left it. It had a button here, a momentary switch, but we gutted that and hit it with some Cat5 cable here, so now this is controlled by our PLC. And power supply, DC power supply is just plugged in all the time back here. This was a stripped out bit extension I had from working on my house. It just poked a hole in it, ran a string through it, and so it wraps up pretty reliably now. Had this little bit on here already, so that works pretty well. And so that just pulls our string, lifts up the shaft, or the little trap there, and releases our balls. We got some ball bearings here. We had some laying around, and we got some out of some toys and stuff. Just hot glued, did this the one day, hot glued some pieces of cardboard in there and made a little chute. And so when the doors lifted up, boom, there goes our balls. This is actually a piece of Smurf tube, ENT conduit. And so those balls get released out of there, put the little tape there to kind of cushion the fall when they start falling. And it just rolls down the thing. Now we got kind of crazy one day with the conduit bender, and so just wanted to see how much of a curlicue you can make, I guess. And so we ended up using this. This is an old base out of a panel, actually, here at school. It was just the quickest and most expedient way to get that to work. All this stuff is from school here that we found, other than the drill. I did have to buy a piece of all thread out there at Lowe's and a pulley, but all this rest of this stuff, string I found at my house, all the rest of this here is just junk we found laying around at school. So the panel, like I said, is just gutted. It's just, you know, an empty shell, the casing here, but we just used that to mount the drill on because it was quick and we didn't have to spend a lot of time. Probably could have made it look better, but we spent every waking moment at the school here, from before school to as long as they let us stay after school, pretty much almost every day, trying to get it this far. Anyway, we wanted these balls to come down here and roll into a cup or something, trip a limit switch, but we ended up just going with the proc sensor here for sake of time. So they just kind of roll back here and just kind of go nowhere, but it does trip our procs. And so we got the 3 balls, they trip our procs, which goes to the counter on the PLC. And so once that counts 3 times, it lights up the couple of lights over there. And then that will trigger our next thing, which is the solenoid valve. All right, so then the solenoid valve, this monstrosity here. So I kind of had an idea for this for a while. I wanted to build something I could dump all my used motor oil into and have a switch there, something reliable. Something easy to dump oil out of an oil pan in, so you don't have to stand over there with a funnel trying to dump it into a jug. But then you could just dump it in there real quick, get your jug ready, bring it down here, hit a button, let your oil drain in while you're standing there, not be take too much time. But I don't know if it'll ever pan out for that. But found all this wood at school here. Had some of this pipe laying around in my barn. Had to get a couple of fittings. That's a 4-inch to a 2-inch reducer. A couple of pieces here. Opted for it was a little bit of money, but I had to get the 2-inch shut off. I'm glad I did, just in case. This is a 12-volt solenoid valve I got off of Amazon. They have them in 120, 24 volt, all kinds of stuff. We opted for the 12-volt DC option. Just a little 45-degree elbow there to channel it into our water a little easier. But basically, there's just a whole, I don't know, 2.5-inch or something hole saw there, whatever, 3-inch maybe, drilled in there, kind of centered. Somebody had made this wood situation, I found it at school, both pieces, so they're a little sketchy. Tried to paint it, had half a can of silver laying around, half a can of red, and I guess that's pretty much where it stopped. Probably should have got a can of black spray paint and tried to hit it up, but anyway, got a 4.5-inch actually hole saw. That's schedule 40 PVC, yeah, schedule 40 right there. So it is a little thick-walled for this application, but I glued it all together, kind of got it in the center there a little bit, kind of measured it up, and then that holds the top piece, and then this piece here, it just sits there. Gravity holds it in. So we dump a little bit of water in there. We got a little 32-ounce Nalgene over here because we can get it kind of up in there above the ceiling tile. About 3 bottles of those, what we use for this here. This trough, we had a not bigger trough, and it was white, and we wanted to mix up the water, nice blue like water, looking kind of feel about it. But this is actually out of the back of my pickup truck. It's a little organizer tray for single cab, and you can put tools and junk in there, but it's what we had for the time being. So we ended up going with that, and only needed the 3 Nalgenes or so to fill it up pretty good, and so that ended up being good. We didn't want to sit here and dump a ton of water out waiting, and I think I calculated that this is about 2 gallons, maybe 3 gallons. I think it's about 2 gallons actually in that pipe or so. They would hold, maybe it was 3, I can't remember now, but anyway, our 3 Nalgenes got us where we needed to go. And so solenoid valve comes, lets the water out, and then we wanted to make a float switch. Didn't get around to it again. We kind of ran out of time, and all this took a lot longer than we anticipated, but we got pretty good at hooking up our proxies and stuff there at the end. But anyways, the water fills up. It's on about a 10-second timer. It pretty much lets all the water out. We kind of got it dialed in. And anyway, after that timer, it activates our fan here. So the fan, this is a power supply out of a computer. Mr. Klingsmith had him laying around here at school. And so we actually have 12 volts, 5 volts, 3.3 volts in here in the ground. So basically just kind of hardwired it to the 12 volts and then switched on the AC plug back here. So that's our other extension cord. It was just the quickest way to go. again. And we were kind of running out of relays after a while, so we could use the 120 volt ice cubes for that. We got a lot of those. 24 volts are kind of hard to come by. 24 volt AC, and then 24 volt DC is even less. And then, you know, we had our 12 volt car relays. But anyway, we used the AC 120 on that. So I'm not real sure where this fan came from. There's a couple of them laying in the closet here at school, so we just used that, zip tied it right to it. Perfect. So it worked out exactly what we needed for. So this little guy here, Noah kind of came up with this mostly. This is his boat he had as a child. Hasn't seen it in about 5 years. Walked downstairs in one of his old toy boxes and reached in, and it was about the first thing he grabbed out. So that was pretty easy. Went through a couple of different designs with this. So this is some 14 gauge, maybe it's 12 gauge. I guess it is 14 gauge THH head in there. He came up with a little sail thing. And of course, to sail, I mean, in the state we're living in right now, I mean, we got to use the mast as the sail, right? So we went for that. The boat, it actually was hot glued there for a minute. A couple guys helped us out with that. Let's use the hot glue gun. It got very tipsy, top heavy. We needed some counterbalance, and so Noah was trying to bend the thing around. It wouldn't work enough. Ended up using the duct tape, got that going. But then we thought it would be way too big, but it's a giant ball bearing down there for this boat anyway. Duct taped it to it in the back and put the mask on here. It was sitting way back and way down in the water, too far back, like crazy. But he tilted the mask a little bit forward, and it floats pretty darn good. We are using kind of that's also where the little trough sides helped us out, because it does let it kind of ride along there a little bit, help it glide along. See, actually, we're about to take on some water there, but you know, it worked pretty good. So we were really happy with that. It was a pretty big hit. I haven't seen anybody here at school use water in their projects before, so we kind of wanted to, you know, go outside, think outside the box a little bit. A lot of people do games, so anyway, boat comes down here, blows down. Here's our other proc sensor, Omron NPN. We got it hooked up to 12 volts as well, so it comes down here, and I don't know if you can hear that again. That's a relay clicking over there. And that's pretty much the end of it. That's what stops our fan. And it also activates our drill. And so now the drill. So we knew what we wanted to do at the end here, but we weren't sure how we were going to do it. I kind of had an idea of what we were going to do, but wasn't sure if it was going to work. So again, quickest, cheapest option we had. I had some leftover all thread, and me and Noah kind of got this thing here hooked up, got some nuts there. These are actually from drilling holes in my eaves of my house. I was putting in some outdoor lights that we needed for the back door and stuff, and so I had those. Figured we could make a little pulley kind of spindle thing here so it'd hold our cord, paracord. Got that, found that in the barracks room when I was in the Marine Corps. So still carrying it around 5 years later, and it's been good to have it around. That's what we're using to lift our box with. This drill I had laying around, a little Harbor Freight right angle drill. The idea was to just zip tie the trigger on this puppy and then activate the power cord using relay. And turns out it's a little bit fast for that. We didn't really mess around with the gearing much. We just like, how can we just vary the speed of this a little bit? And like I said, fastest option was to grab the clamp and you know, just squeeze that trigger just right. So then we were left with how we're going to mount this thing. Zip ties obviously weren't going to cut it. Found this clamp. It's a 2.5 inch down in the lab, just sitting there, and had a hammer drill, you know, handy, and so we put a couple of red heads in there and some screws. No big deal. It held it down. That one clamp is holding that drill. It works good. I'm surprised it does, but it works good. So got on a couple of cinder blocks just so that, you know, they won't move and stuff like that. String goes up in the ceiling. which we didn't drill into the ceiling. There's an old ceiling up there. We got a 2x4, just set it there, tied the pulley to it with some more 550 cord. And there she comes down. Got a little carabiner for quick release here. And so, I'll just go ahead and raise it up here, activating it with the button. So, this is a box actually out of a printer I had from one of my old jobs. Great big box. And so the drill lifted it up just fine, had plenty of power. However, once it was up in the air, it started to fall down because, you know, it didn't have a brake on the drill and it was too heavy, it wouldn't hold it. So we ended up having to gut the sides out of this box and to shave the weight. And so this is our wrapping paper job. So the wrapping paper definitely became necessary also for cosmetics, but so the box is barely hanging on. It's just a shell now at this point. But that got us weight shaved down enough so it would hold there. So as you've seen, that's pretty much the end of our project. This tree I've had for, I don't know, since me and my wife got together 5 years ago or so. She had it. It ended up in our garage after we moved in together and all that stuff. Kind of been trying to throw it away for a couple of years and keeps getting thrown by the side and I forget. Anyway, I'm glad I didn't because it's perfect for this project. The guys got a couple of connectors here, EMT, GMT connectors and stuff, 4-inch square, duct taped it to the floor, absolutely perfect. I don't think I mentioned that. I think I mentioned when we were talking about the relays that this is on a normally closed portion of a contact, and the drill normally open. We activate the coil, lights shut off, even though they're on all the time under the present, which you don't know. Lights shut off, the drill turns on. When the drill's finished, it's on a timer that we adjust as needed on the PLC because sometimes our trigger comes a little loose and we have to adjust it, and it comes a little faster, a little slower. And so once it's finished, then the coil is deactivated. The normally open becomes normally open again, and normally closed back to normally closed. And our lights come on, so it gives it a real nice feature. And it's really not that complicated. Like I said, it's on one split wired duplex receptacle. So 2 extension cords going in the same receptacle. Pretty easy. We actually did that that was like the last minute kind of thing, just an extra added little bonus for our project. All right, and the last little feature wasn't really graded criteria or anything, but we wanted to add some music to this, and so I had this Raspberry Pi 4. Still learning how to use it here, but found the Python program somebody had made on the internet and kind of went in, edited it, kind of made it our own, added some music to it. Had this PIR sensor. We went off the GPIO pins in this here. Powered by 5 volts, and it worked initially. We're kind of having some troubles with it, so I don't know what's going on. But it has a really wide range on it, and so we just duct taped it to the underside of the cornhole board here, and it would go off with the bag. I would sit at the computer just in case, so I could activate the music. There was a little delay in it, but it worked okay. It's not near the quality of our Proxes here at school. I think we got like 5 of these for like $6. They're not probably the highest quality things. But anyway, messing around with that is pretty neat. Mr. Clean says there's a lot, Raspberry Pis and Arduinos, stuff like that. So it was a cool little feature. We ended up just here at the end when we were showing, just to be safe, I just activated it with the keyboard as soon as I saw somebody made the cornhole shot, just in case. And it would play off our Bluetooth speaker over there. We got up there in the corner. That was just a little cheap thing. Works pretty good though. So that was kind of a cool feature we wanted to add in. There's just some added mesh wiring and stuff. We got a computer screen up there. Had to deal with, but that was just a little bit of added bonus in there for us. But this is our PLC project, and Triangle Tech here at Falls Creek. Yeah, it's Noah Wilson, Zach Galinis, Tyson Blake, David McCracken. This is what we came up with, a little Rube Goldberg contraption, I guess, here. They said it's unique, kind of hasn't really been done, so we're going to do something a little different in the game. A lot of the guys came up with some pretty sweet games this time, so everything works pretty good. So, but this is what we came up with. We're happy it turned out the way it did, as reliable as it is, and you know, like to do it again someday. We'll see, just for fun, if we can come up with some parts. But yeah, thanks for watching.